3, Section 1, Graphing Inequalities. Remember the inequality signs. This first one is read less than, greater than, less than or equal to, and greater than or equal to. If you remember, when you're graphing inequalities and you just have a less than or greater than, or your symbol without a line underneath it, your circle is going to be open. And when you have the less than or equal to or greater than or equal to, your circle is going to be closed at the point. We graph inequalities on a number line. Like I just said, for less than or equal to and greater than or equal to, we put a closed circle. And for less than and greater than, we're going to have an open circle. Read the inequality and shade the numbers that make it true. It's important. There's a lot of different tricks that people say. If your variable is written on the left side of the inequality, then you just shade in the direction that the arrow is pointing. And there's a lot of different things, but make sure that you read the inequality, understand that what it's saying, and then if you can understand what it's saying, then you can tell which way you need to shade. And that's going to be the easiest way. There's not different rules that you need to think of that aren't going to always be true. If you can just read and understand it, then graphing it should be okay. What is the graph of 4 is greater than or equal to b? This can be read 4 is greater than or equal to b, or you could say that b is less than or equal to 4. So you can read it both ways, or you can flip everything around. When you read it, b is less than or equal to 4, first of all, we know we need a closed circle because it's less than or equal to or greater than or equal to. And then we know that we need to shade it to the left. We need to shade in all of the numbers that are less than 4 because b has to be less than or equal to 4. What inequality represents the graph? So now we're going to be given a graph and we have to write our inequality. If you look at example A, we have a closed circle at -2, so we know that our variable has to be something or equal to the -2. And we're shaded to the left. We're shading in all the numbers that are less than 2. So the inequality is x is less than or equal to -2. If you look at example B, we have an open circle at 1. Because there is an open circle, we know that it's just going to be greater than or less than, not equal to. Notice that we're shading all of the numbers that are larger than 1. So this inequality would be x is greater than 1. Is each number a solution of 3x minus 2 is less than -1? A, it asks us if 4 is a solution. To find if it's a solution or not, we have to see if it makes the inequality true. So we need to plug in 4 for x. We have 3 times 4 minus 2 is less than or equal, less than -1. Well, 3 times 4 is 12 minus 2. 12 minus 2 is 10. 10 is not less than -1, so this is not a true statement. So it is not a solution of 3x minus 2 is less than -1. Now if you plug in -3 for b, we would have 3 times -3 minus 2 is less than -1. 3 times -3 is -9. -9 minus 2 is -11. Now -11 is less than -1, so -3 is a solution to the inequality. The last example asks us, what inequality describes each situation? Be sure to define a variable. For example A, it gives you a sign, and it says you must be at least 4 feet tall to ride this roller coaster. Well, if you have to be at least 4 feet tall, you can be 4 feet, or you could be taller than that. You could not be, like, say, 3'11". That's not going to work. You're not tall enough. So in this case, I'm going to write an inequality h for height has to be greater than or equal to 4, And in this case, I forgot to put my units, but it is 4 feet. B says speed limit 35 miles per hour. If the speed limit tells you the maximum speed that you can go. So to be within the guidelines of the speed limit, your speed, or S, would have to be less than or equal to 35, because you can go 35 miles per hour or less, but you cannot go over 35 miles per hour, or else you might get pulled over and get a ticket.